As part of the summer CAD training, this is an explanation video on motor curves and ratio calculations. So motor curves are basically a way to gather information about 5 parameters: speed, torque, current draw, power, and efficiency. And there are a couple of key metrics that you should be able to identify and know what they mean on a motor curve. So number 1 is stall torque. Stall torque is calculated when RPM is 0 and the motor is drawing at full stall current. It's the maximum torque that a motor will ever be capable of outputting, but it's important to know that it can't output this forever for a variety of reasons, but one of which has to do with waste heat. So a motor releases waste heat when it's running, and usually the motor body can dissipate this heat. But in this case, the waste heat will get too much, the motor will overheat, and it will fail. Next is stall current. Stall current is the maximum current that a motor is ever going to draw. It's again measured when RPM is 0 and when the motor has torque. It's the point where the most waste heat is generated. Free speed is the fastest angular velocity that a motor is capable of producing. It's calculated when the load on the output shaft is 0. So it'll look something like this. Essentially, it's just going to be free spinning. There's nothing on this shaft. Free current is similar to free speed in the sense that it's calculated when the load on the output shaft is 0, but it refers to the current draw at that point, and it's the lowest current draw possible for that given motor. Next is peak power. Peak power is the maximum amount of mechanical power that a motor can produce. You're generally recommended to stay to the right of this point, and I'll explain why in a second. And finally, max efficiency. Max efficiency is the optimal relationship between input and output power. It's generally best practice to use a motor around maximum efficiency just because it's better for motor life, power consumption, and reliability in general. Really quick before I go back to peak power, I hope you know this by now, but torque and speed are inversely proportional, so that is what their relationship looks like. And that is important just because this graph has speed as the independent, but some graphs have torque, and so that obviously changes the location of some of these values, and you should keep that in mind. But back to peak power. So the power curve refers to mechanical power, while current draw refers to electrical power. And the power curve is a parabola, as you can see. So let's say I wanted some value, some mechanical power output. Let's call it X. Well, there are 2 points where I can get that. One is point A, and the other is point B. Now, a huge difference between these 2 points are the electrical power required for them. So here at point A, you can see that the electrical power is significantly more than at point B. So essentially, once you go to the left of peak power, the motor is drawing more electrical power just to produce the same or even less mechanical power. Next up is the Falcon 500. So the Falcon 500 is a brushless motor. It is the most powerful motor that we can currently use in FRC, but while we generally use the Falcon 500 for most things, there are some cases where you might not want to. For instance, this year, if this was our robot, we were pivoting this entire thing off of an approximately 30-inch arm. I think it was 30 inches. I can't remember off of the top of my head, but basically, obviously, we wanted to keep the end effector, which was the intake, as light as possible. We didn't need it to spin very fast, we didn't need it to pick up something very heavy, so the speed and torque required were pretty low. Therefore, the overall power required was pretty low, and we could get away with using a Neo, I think it was a Neo 550, if I remember correctly. So obviously you don't need to use the Falcon 500, just try and use whichever motor is best for your needs, but we tend to use the Falcon 500. You can see here on the motor curve, there are all these significant values, and another thing to keep in mind is this is the efficiency curve in red, and this is the maximum, I think, for a Falcon 500. If I remember correctly, max efficiency is 87.6%, I think. Yeah, that should be right. But basically, once you go past that, the drop is pretty steep. I know here it doesn't really look like it, but it is pretty steep, so just try and stay around max efficiency and keep that drop in mind. Another thing is, so in FRC, the PDH that we use has 20 high current channels, and they support up to 40 amps, so you don't want to go over that. But then, how do you change the torque to accomplish a given task? Well, you need to change the gear ratio. And this is really important because if the ratio is incorrect and more torque is actually required for the task, then your motor will draw more current to try and still do what you're asking it to. But what's going to actually happen is your circuit breaker will trip because the motor is drawing too much amperage. So just keep that in mind when you are trying to create a gear ratio. It's really important because especially for certain mechanisms like, I don't know, like a climb, it could be really dangerous if your circuit breaker trips because you can only use the motor once it reconnects, and by that point, well, your robot's on the ground. And how do you calculate gear ratios? Well, there are a couple of websites and spreadsheets that you can use. The one that I like to use is AMD Calc. It's really intuitive. The website pretty much does everything for you. But there is another one called JVN Calc that I know some people like to use. I personally don't really like to use it, but if you want to know how to use it, there are plenty of videos out there on how to, and feel free to come to me if you have any questions. So this is just a really quick explanation on how to use AMD Calc. Go to ambcalc.com. They should have a robotics calculator, and then you want to go to the mechanism ratio calculator. So first up, select your motor and make sure that it's set to Falcon 500. I'm just going to be inputting the values that we used on the pivot for the charged up 2023 robot. So we used two motors. I think I mentioned this earlier, but approximately 30-inch arm. The load force was the weight of the end effector because the game pieces just weren't that heavy. It was probably closer to 10, but let's just say 15 just to be safe. And then you just hit max efficiency. And then it gives you, like, you don't need to use, obviously you can't even use this number. You can't use 187.14 to 1. You can't use that ratio. But this is just a good number to try and be around just because this is the maximum efficiency and you want to stay near that number. So just take into account the tooth count of your sprockets and your gears and just the available ones that you have. Obviously, if you need to order some, then you can do that, but just try and use the pieces that we have in the lab right now and just try and create a ratio that is somewhere around this value. Another great feature that you can use on AMD Calc is, let's say I took this ratio and approximated it using the sprockets and gears that we already have. Let's pick an easy number. Let's say I wanted a 200 to 1 ratio. Well, I could use a 100 to 1 sport gearbox for that and I don't know, another 2 to 1 ratio. Well, that gives me the 200 to 1 ratio that I'm looking for. You can click on this, it'll drop it down to here and give you all the information that you need. So you can check the current draw per motor to make sure that it's not over 40 and it's about 18, so you're good on that front. You can see the motor efficiency is 78.9, which is still relatively close to max efficiency. And you can also check, because this was a pivot, you're only concerned with the rotational, loaded and free speed, and you can check those over here. That concludes the motor curves and ratio calculations video. If you ever need to find information on any motors that you might want to use, you can go to the slide deck to this slide and go to links 3 and 4. That will bring you to the VEX Pro website, which will give you information in the form of motor curves as well as data tables on any of the motors that you might want to use in the future. Before moving on to the next part, please complete the quiz linked in the top right.